First off, you'll have to right click and extract all. Once you've done that, log into Wakari. We're going to open the download box and drag and drop. Click on the upload. Once it's finished, we double click on the notebook, APM Notebook E. So this is the midterm. You'll notice that a lot more is in the notebook rather than hidden behind the scenes. So we start out with quite a large number of imports. We're going to be using sklearn, which is where we have the confusion matrix, ROC curve, AUC, that sort of thing. You'll need to put in your username. And you uploaded this file when you did those 4, and now you do run -I, and that will load that. The first problem is on breast cancer, so we'll load the data. We'll split the data into the class, which is either susceptible to cancer, breast cancer, or not. So you can think of this data as a diagnostic test, cancer screening. Now, for the purpose of the midterm and the classifier, we split this into training set and a test set, and actually these are just sets of indices. We apply the class and data to these different indices to get the actual training and testing data. Now we're going to look at a binary classifier. Notice the criterion, max depth, min samples, split equals 2. So you'll leave this at entropy, but these two you'll want to change as part of the exam. This actually builds the decision tree, and now we can view the decision tree. Notice that we don't see anything here. That's because of this little shield right here. It says this page includes script from unauthenticated sources. So we will load the unsaved script, and that's going to force us to leave this page, so we'll have to start over. And so because of the clearing the pop-up blocker, we're back to where we started. So let me close the file browser, get back to where we were. Notice it's 11 and 12. We actually didn't stop the Python kernel. All we lost was the web page. So we're back down here to where we can view the tree. And you can see the tree here. It's a little hard to look at, so you can click toggle view, and that will bring up a separate view, and you can make this as big as you want. You can fill the screen, and if it's a box that is colored light blue, you can click on it and it shows you what's underneath, and you can see the actual tree. And what you'll notice is that it's very deep, almost certainly is overfitting because it's so large. So we need a smaller tree with good performance. Still going. Now once we've created the tree, we can do some predictions. It should be decision tree, what we have up there. Now the confusion matrix. Notice you'll need to put it in percentile form and calculate the basic metrics. The ROC curve. Thresholds we'll actually use later on. The receiver operating characteristic and the actual ROC curve itself. But this is for a almost certainly overfitting tree. The second problem will be working with the recommender system, the movie lens. So we'll have to load the text. You remember, this is large data. I've made it compact as much as possible, so we still may have some issues here. This is a histogram of it. We have to change it into a sparse matrix. This is a method for splitting it into a testing and a training set. And we're going to look at movie number 588, which is the 1989 Batman movie. And what we're doing is we're dividing this into 50 positive and 50 negative in the test set, 50 who rated Batman highly and 50 who didn't give it a good rating. And we're going to see if we can use a k-nearest neighbor network as a classifier, and can we predict if a user is going to rate Batman high or low. This is the movie data matrix. Notice I say this may take a few minutes, and I'm not exaggerating there. And you see that has to count down. Okay, it's finished. You could actually avoid doing this in the future by simply looking at the store magic. So what we're going to be doing is we're going to be looking at 4 different k-nearest neighbors classifiers that can predict who's going to like Batman and who's not. So movie predict will make the actual predictions, and it intentionally is going to look a lot like problem 1. We make the predictions, our receiver operating characteristics, so we're starting out at 0.67, and we keep going like that. We have the undirected, the OR approach, the AND approach, and we eventually get to where we can do some rewiring. You might want to look at lecture 3. It's not important you understand how this rewiring is happening, just that why we're rewiring, why we're working with the AND case. And there are more things to look at here. Essentially, you're going to write a report. Part 1 of the report will be on the breast cancer problem. Part 2 will be on this problem. In each case, you're trying to pick out which is the best.